Recording jalan dulu, then we'll start. Alright, so let us start our class today. So today we're going to look at chapter 9 again, 9.2 graph. So we are going to learn how to sketch graph. Okay, so how many types of graph do we have in this topic? Okay, right, so let's see. So first things we have a ST graph, okay, XT, which is a displacement time graph. This is a graph that you need to know. And then the second type of the graph is the VT graph, velocity time graph. And the next one is the acceleration time graph. Okay, so these three, they are the most fundamental graphs that you need to know. And other than the graph itself, you need to know how to sketch, how to form the equation as well as how to differentiate the equations. Because as you can see in the questions one, you're just given one equation, which is the equations for x. So based on these equations, you need to sketch three types of graphs. So you need to do differentiations. You need to have equations for a v, and then you need to form equations for a, okay, AT graph. So other than these three fundamental types of graph, okay, you also have to know how to sketch graph for energy. So we have three types of energy. Okay, we have a UX graph, and then we have a KX graph, and also the EX graph. Now, what does it mean by X? It's a displacement. Okay, you have a positive displacement, you have negative displacement. So these three graphs, you need to know how to sketch the shape, right? So yeah, basically that's it. Okay, and previously they have one more types of graph which is no longer in your syllabus. I think is a UT graph, KT graph, and ET graph. Okay, so today we're just going to focus on this six type of graph. We are not going to look at the energy against time graph. All right, because I think that one is no longer in your syllabus. If you found that in your revision books, you can just skip it. Okay, so first questions. The displacement of a particles in simple harmonic motion varies with time t according to the equation x equals to 2 sine 2 pi t. All right, so this equation, the first thing that you need to know is to compare, okay? That you need to do is to compare it with the general equation. So x equals to a sine omega t, right? So from here, you can either differentiate by using the equations with value, or you can differentiate it by using the general equation. It's up to you. All right, you see which one is easier for you. As long as you can get the right answer, then that is the best method for you. So questions A, displacement against time graph. So how are we going to sketch the graph? First of all, you look at the questions. Questions tells you it's a displacement against time. So we are going to plot a graph, okay, that have a y-axis, which is our displacement, x, and then x-axis is the displacement time. Okay, so x is in terms of what? In terms of cm. Okay, so you need to know the unit. So the unit will be given in the questions. You just have to take note. You just have to pay more attention to find the unit. So x is in cm, and then t is in second. All right, then what are we going to do next? Okay, according to the questions, we have amplitude, which is equals to 2. Okay, so you compare the equations by comparison. Amplitude is equals to 2. So I'm going to label my amplitude here, which is A. Oops, A is equals to 2. So this is 0, and then this is negative 2. All right, so now I have the amplitude. What am I going to do next? I'm going to look at the shape. Which part of the equations tell me the shape of this x against t graph? So you look at the equation. Equations tells you it is a sine function. It is a sine graph. So what is the shape of a sine graph? Very simple. So now you have a sine graph and there's no initial phase angle. So no initial phase angle. Okay, initial phase angle is equal to 0, means your object, your graph start from origin. Okay, start from 0 because this is a sine graph and there's no initial phase angle. So now I'm just going to sketch the shape of a sine function. All right, done. That's it. Okay, that's it, the shape. That is how we sketch it. But one last thing, don't forget, when you sketch the graph, if you're given the value, then you need to include it in your graph. So what is the value that is missing? That is the period. Time taken to complete one oscillations. We have the information in our equation, which is 2 pi is our omega. Okay, so omega we know is equals to 2 pi over t. So t is equals to 2 pi over omega. According to questions, my omega is 2 pi. Okay, my omega is 2 pi. Therefore, t is then equals to 1. Okay, 1 second. Therefore, you label it in your graph. This one is your period, which is equals to 1. Done. This is a complete sketching. So usually this graph itself, it worth 3 marks in your exam. All right, 1 marks for the labels that exist, 1 marks for the value, okay, the values that you calculate the 1 second, and then 1 marks for the shape of the graph. So this graph is very simple because there is no initial phase angle. So your graph can straight away start from 0 because it is a sine graph. If you are given a cos graph, then it starts from amplitude, right? So this is questions A. Simple. Now, how about questions B? If you look at questions B is asking for V against time graph. So now you look at the equations. Equations, you have x equals to 2 sine 2 pi t. All right. So 2 sine 2 pi t, that is the equations for x. Now we want equations for V. So in order to obtain equations for V, we need to differentiate it. V equals to dx over dt, which is then equals to 4 pi cos 2 pi t. So this is my equations. Okay, this is my equations. So now look at the question. Question tells you is velocity against time graph. So this is V, this is t. What is the unit for V? Well, since my x is in terms of cm, my V would be cm as -1. And the times would be in terms of second. Okay, times is in terms of second. So now you look at these equations. Again, these equations, you don't have initial phase angle. What you have is just omega t. So phi again is equals to 0 radian. So you're going to keep the original shape of the trigo function. So now you look at the questions, you have cos. Okay, so we just sketch the shape of the cos here. Now the next questions would be, what should we put as the maximum value in our graph? This is a very common sin mistake in the exam. Students often put A in a graph, which is wrong. What you should put here, okay, when it comes to a VT graph, is no longer A. You have to put A omega. Okay, because now the value in front of the trigo function is A omega. It's no longer just A. So you need to put A omega, okay? If you look at the general equations for your V is V equals to A omega cos omega t. Okay, cos omega t. So the things that we need to put in our graph is A omega, not just A. This is a very common sense mistake in the exam. So the value here, it should be 4 pi, okay? Not 2. It should be 4 pi. Okay, bukan 2, tetapi 4 pi. So for period, okay, period is the same because we are still using the same omega. So it's 1. Okay, 1 complete oscillations, the time taken is 1. So that is a graph for velocity against time. Next one would be A against T. Okay, I'm going to do it right here. So question C. So V is equals to 4 pi cos 2 pi t. And we know A is equals to dV over dt. So you differentiate 4 pi cos omega t, you're going to obtain negative 8 pi square sine omega t, okay, which is 2 pi t. So this one actually comes from the general equations. A equals to negative A omega square sine omega t. Okay, so this one actually is coming from this equation. So how are we going to sketch the graph then? Now you try to identify the maximum value first. The maximum value now is no longer A, is no longer A omega. The value in front of sine is A omega square. So this would be the maximum values that we're going to put in our graph. So let's sketch the graph. A against T. The unit for A, since my x is in cm, so A is cm as -2, right? And then time is still in second. So my maximum value now is 8 pi. Okay, it's 8 pi square. right? 8 pi squared, 0, and then negative 8 pi squared. Okay, negative 8 pi squared. So what am I going to do right now? I'm going to go back to my equations. If you look at the equations, what is the types of the functions, the trigo function that I have? I have sine here, but not just sine, but it is a negative sine function. So negative sine, what does a negative mean? Negative, it means it is an inverted sine function. Terbalik punya sine. So the normal sine function is like the one in questions A. When you have a negative sign, then you just flip it over. So which means now the graph is going to head towards negative first. Okay, so it go to negative first and then go back to positive. So this is our graph for A against T. So the period is still the same, it is equals to 1. So now this is a complete graph, okay, complete graph for A against T. So basically it's very simple. Okay, all you have to know is how to differentiate the equation, and then where is the maximum value? What is the maximum value? Okay, where can you find the maximum value from the equations? And then the last one is the shape. Okay, it's the shape of the graph. So how to determine the shape? You look at the trigo function. If it is sine, then you give it a sine function. If it is a cos, then you give it a cos shape. If it is a negative sign, then you just flip the sine wave over, the sine graph over, right? So if it has a initial phase angle, then you just shift the graph. Okay, graph shifting, I will keep it for chapter 10 if I'm not mistaken. Okay, we'll do it in chapter 10. So right now we learn the fundamental shape first. Okay, we learn how to sketch the fundamental shape of the graph. Okay, so now I give you a 3 minutes to write it down before we proceed to next question. All right, if you are done, you may try next question first. Next question is exactly the same as this one, but you're going to start from x equals to 2 cos 2 pi p. You're going to start with a cos function rather than a sine function. Okay, so I give you 3 minutes to write it down. If you are done, you may try second question first. See how are you going to sketch a full marks graph. Okay, if you are done, I encourage you to try questions 2. Okay, because graph sketching is a very common sense questions in the exam. Okay, so questions 2. Questions 2, now you're given a cost function. So remember the things I told you before. If you're given cost, then you have to do a new set of differentiations. Okay, so cost, the general equations obviously should be in cost. So x equals to a cos omega t. Okay, so which means now you have a, which is equals to 2. Again, it is in terms of cm. And then your time, t, okay, now you don't have time, sorry. So you have omega, okay? Omega is equals to 2 pi radian, so radian per second, because your t is in second. So if it is a t is in second, then radian is per second. If t is in minutes, then the omega should be radian per minute. Okay, so that is how we determine the sign in our calculation. All right, so the next one, okay, what are we going to do next? Again, let's look at the questions. Questions 1, okay, displacement against time graph. So A, we're going to do a differentiation, not differentiation, sorry. We're going to do a sketching, the y-axis, which is a displacement, our x in cm, right? And then t is in terms of a second. We have a cost functions here. Okay, we have a cost functions here, and then our a is equals to 2. So let's label a first, 2, and then negative 2. So how are we going to sketch the graph? Since you have a cost graph here, okay, so we're going to sketch a cost graph. Oops. A very simple types of a graph. Okay, so this is a cost graph. So this is our 2. So again, what is the values of the period? You need to label period. Period is a must in our sketching. So we have omega again equals to 2 pi, which is equals to 2 pi over t. So t again is equals to 1 second. Therefore, here should label as 1. So done. Okay, so the things that we must include in our graph, label, okay, the axis, and then the numbers. Okay, you label the numbers. So these are the things that you need to include in your sketching. And the last one is the shape. Okay, so shape 1 marks. All this value it worth 1 marks, and then label the axis with unique 1 marks. Usually that is how it works in the exam. So now I give you 5 minutes. I want you to try questions B and question C. Okay, 5 minutes for you to try questions B and question C. I want you to learn how to do a sketching. All right, so now you have the wait, yeah, okay, here. So you have the general equations. All right. So you have general equations, x equals to 2 cos omega t. What I want you guys to do, you guys learn how to differentiate it first. Differentiate and then sketch a graph. So I will give you the answer after 5 minutes. All right, I want you to try it first. Okay, so can you get answer? I hope you can get answer. So now let's see what is the answer for questions B. So questions B, again, you have a velocity against time graph. Okay, so you need to differentiate equations. So let's begin with the differentiations. V equals to dx over dt. Okay, you differentiate cos, you will get negative sign. So now you will have a negative cos function. So negative 4 pi cos 2 pi t. Okay, so the graph, it should look like this. So I will straight away give you the answer. So V is the cm as -1. T again is in terms of second. So now the shape of the graph will be an inverted cos function. Okay, so inverted cos function is going to, inverted sine, sorry. So this should be sine. So inverted sine function, so it should be like this. All right, so with here as a 1, and then here is a 4 pi, and then 0, negative 4 pi. All right, so remember the most important thing is don't get the maximum value wrong. It is no longer A, but it's A omega. Okay, it's A omega. So question C, okay, question C, now you're going to look at A against time graph. So we have A equals to dV over dt, which is then equals to, now you differentiate sign, you are going to get a positive cos. But original equation, they come with a negative sign. Okay, so you need to keep the negative sign. So you have negative 8 pi square cos omega t, which is your 2 pi t. Okay, 2 pi t. So now you have a negative cos function. So you are going to sketch it. This is a and then cm as -2 times is s. So inverted cos, because you have a negative sign here with a cos. So now its shape is like this. Okay, so terbalikan sign graph untuk cos. So now again you have a 1 second here. Okay, and then this one is 8 pi square. Negative 8 pi square, 0, and then the maximum value would be 8 pi square. So that is the answer for questions 2. So it's very simple, okay? Questions 1 and questions 2, if you can understand, you know how to sketch the graph, then basically you know how to sketch all sort of graph for AT, VT, and XT. All right, you need to know how to sketch. You need to know what is the information that can be found from the graph. Okay, because quite often it will be asked in the question. Sometimes question will just give you a graph. Then you yourself have to know what is the information that you can get from the graph. Right, especially in terms of the maximum value. So biasanya pelajar salah faham. Dia ingat maximum mesti A sahaja. No, not necessary. Okay. Untuk XT graph dia adalah A. VT graph A omega. AT graph maximum dia A omega square. So from here you can then determine the values of A. Okay, by using A omega square and so on. A omega square. So done. Okay, we are done with questions 1 and questions 2. So I give you 1 minute to go through your answer to check, see whether you got the right answer, and then we will proceed to the next one. Okay, kita akan sambung ke seterusnya. So 1 minit bagi anda tanda anda punya jawapan dulu. So if you have any question, if there's anything that you don't understand, okay, you may ask. All right, you may ask, or you can type in the in-call message. All right. So let us proceed to next question. So next question, okay, we're going to look at different types of graph now. So next question is about energy against displacement. So sketch a graph of potential energy against displacement. So this is the graph that we're going to sketch right now. So for horizontal spring, whose spring constant is a 95 Nm, So you are given K equals to 95 and M negative 1, and which has a mass, okay, mass which is equals to 55 gram on the ends of it. Assume the spring was started at an initial amplitude. So your amplitude is 2 cm. Neglect the mass of the spring and any frictions with the horizontal surface. So what happens right now here is this is our diagram. So initially, okay, this is a spring. It's being attached to a box, right? So initially, okay, this one is our equilibrium position. So equilibrium position, x is equals to 0 cm. So what happens right now? Now you stretch it. Okay, you stretch the spring and now it begins at a place that is 2 cm from equilibrium position. So this is what happened according to the questions. So questions now ask you to sketch a potential energy against displacement graph. Now, when it comes to displacement, remember, you will have a positive displacement and a negative displacement. All right, when this object is start to oscillate, okay, it will oscillate to the left and to the right of the equilibrium position. It will just keep oscillating. So your graph, okay, your graph, it must come with a negative axis for displacement. And energy, we have only positive value. Therefore, you don't have to sketch a negative part for y-axis. So now I have U, okay, where the energy should be in joule, and then my x component would be x in terms of cm, okay, in terms of cm. Okay, now what is the things that I need to put in my diagram? Okay, the first thing, of course, is the maximum displacement. So maximum displacement, if you remember the definition, okay, maximum displacement in a displacement is our A. Okay, so we are given A equals to 2 cm. So on the x-axis, we are going to have 2 cm is 0 and negative 2. All right, because that is our maximum displacement, maximum x value that we can get. And one more thing, okay, the things that we need to put in our diagram, since we are given K and M, it means you can calculate the maximum potential energy, right? You can calculate the maximum potential energy. So U max is equals to 1 over 2 kx maximum squared, which means this is our amplitude. So which is then equals to 1 over 2, given k is 95, and then maximum x is 2 cm. So 2 cm, you need to change it into meter. Okay, so 0.02, and then square it. Okay, square it. So eventually you will obtain 0.019 joule. So this is our maximum energy. So this is the things that we need to label. 0.019. Okay, now we have to think, what is the shape of the graph? We don't have any other information. What we do have is just half kx squared. So you need to think of it from a common sense. Now you pull the object to its maximum displacement. So what happens when it is at this maximum displacement? Well, we know at maximum displacement, K is equals to 0. Okay, so energy U is equals to maximum value. When it goes back to its original position, where x is equals to 0, so you look at the equation. Equation is half kx squared. When x equals to 0 at equilibrium position, it means our U is equals to 0. And at this point, we have K equals to maximum value. So if the object, it keeps moving towards the negative side, okay, towards the maximum negative displacement, then you're going to have maximum energy again, which means, okay, at x equals to 2 cm, we have maximum U, all right? And at x equals to 0, we have 0 U. And at x equals to negative 2, 1, again, it goes back to maximum U. So you will see a shape, a U-shaped graph here. Okay, a U-shaped graph. So this is the shape of the graph that we are going to sketch. All right. So yeah, this is the shape. Okay. All right. So something like this. Okay. So you sketch it on your books. So here is 0. Okay. Here's 0. Let's see. past 0. Okay, it touched 0 and then it goes to the maximum value. So it is a U-shaped graph. Okay, it is a U-shaped graph where you have a maximum and minimum at 2 and negative 2 cm. So done. Okay, done. This is a complete sketching for questions number 3. So this is how you sketch. You try to think what happened at maximum displacement, what happens at the equilibrium position, and what happened at negative maximum displacement. All right, so I give you 2 minutes to write it down before we proceed to next question. Right, 2 minutes untuk ada catat sebelum kita gerak ke soalan seterusnya.
Madam,
Ya.
saya still tak faham kenapa waktu X is equal to negative 2, U dia maximum.
Oh, dia sama saja konsep dia. Dia macam, okay, kamu fikirkan, kalau kamu compress spring, if you compress a spring, let me continue the diagram here. So if you compress a spring, okay, at this point, it has the most restoring force in it. Okay, so di sini adalah negative 2. So negative 2 cm, this is also at its maximum position. Dia sama macam kamu stretch. At maximum position, you have equations U equals to 1 over 2 kx squared. So ini adalah maximum negative. So maximum amplitude, kita kata dia adalah A. That's why your U is also maximum. Okay, so when X equals to maximum value, your U is also equals to maximum value. And then what happens to this kinetic energy? So if you compress it to the maximum displacement, object it will stop. Okay, kita kata object stop at its maximum position. So you compress it, kamu tekan dia, kamu compress dia sampai negative 2 cm, dia dah tak boleh gerak dah. Okay, dia dah tak boleh gerak. So at this point, apa yang terjadi? V equals to 0, dia stop for a moment. So at this instant, kamu punya K is equals to 0, and your U is the maximum value. Sebab U kamu sekarang dia berada di maximum displacement. Cuma sekarang dia ada satu negative here. Why? Just because of the direction. Okay, so positive 2 mean is on the right hand side of equilibrium position. Negative 2 mean is on the left hand side of equilibrium position. Dia macam kamu swing kamu punya pendulum. Okay, kamu swing kamu punya pendulum. It can has a positive value, it can has a negative value. Okay, the only difference is satu di sebelah kanan, satu di sebelah kiri. So dia macam di sini maximum height, so U max K0. Okay, and then sini maximum height juga, so U max K0. Same concept. Okay, same concept. That at lowest position, H0, therefore U is equal to 0 and K is equal to maximum. So how do I know K is maximum? Well, because energy is always conserved. Kalau satu kosong, the other one mesti maximum. Okay, because we have equations E equals to K plus U. So sama juga at negative 2, because my object stop, K kosong, kalau kita fikir dari segi conservation of energy, U kita adalah maximum. So ada dua cara yang kita boleh tengok. Satu, kamu tengok dari segi equation. So di negative 2, maximum X. Maximum X, dia bagi kamu maximum U. Kalau tengok dari segi equations untuk U. Kalau tengok dari segi conservation of energy, at maximum position, objek tidak bergerak. Dia sudah compress sampai tahap maksimum. Dia tak boleh gerak lagi. So, maximum position, K kosong. K kosong, if you look at it in terms of conservation of energy, your U would be maximum. Okay, because of what? Because when K equals to 0, E is equals to U, which is equals to max energy. Okay, max value. So, boleh faham? Okay tak?
Faham, madam. Thank you.
Okay, good. Okay, now questions number 4. Okay, questions number 4. A 2 kg body oscillates in a simple harmonic motion. If its kinetic energy changes with displacement, as shown in figure right now, so what is the amplitude? So you look at the graph, okay? This graph actually is similar to the graph for potential energy, just that the shape, okay? They have inverted shape. Why? Well, exactly like what I told you just now, okay? When K is maximum, when U is maximum, K is equal to 0. So at both end, okay, you have a maximum potential energy. That's why both end here you have 0 kinetic energy, okay, which is at its maximum displacement. So when it's at equilibrium position, when U equals to 0, our K is maximum, okay. So if you look at the shape, at y-axis, which is our equilibrium position, we have U equals to 0. But if you look at K against X graph, we have maximum kinetic energy. Okay, so basically kinetic energy dengan potential energy dia punya graph terbalik sahaja. Alright, terbalik sahaja. That is because of the conservations of energy. Okay, so now that we have this graph and we know, okay, 0.2 and negative 0.2, these two value, actually they are our maximum displacement. Okay, maximum displacement. So which means at the same times, it represents our amplitude, our A. Okay, because you have X here. So maximum X is amplitude, is A. So questions 4A, amplitude is equal to 0.2 meter. Straight away, you can get it from the graph. Okay, so the second things that we want to calculate is the period. Now, if you look at this graph, we have K, we have X, but we don't have period. So how are we going to calculate period? Now, what we do know is kinetic energy, okay, can be calculated by using omega. So once you have omega, means you have period. Why? Because omega, period, frequency, they are one family. And we know K is equals to, the equation is equals to 1 over 2, okay, 1 over 2 m omega square and then bracket a square minus x square. Okay, a square minus x square. So at maximum, okay, when K is equal to maximum, at K max, okay, we have X equals to 0. Okay, X equals to 0, we have maximum value, which is our y-axis. Okay, when your X equals to 0, we have maximum K. Okay, maximum K. So X equals to 0, K is equals to maximum. Therefore, the equations can then be simplified into K max is equals to 1 over 2 m omega square a square. According to the graph, maximum K is 2 joule. So equals to 1 over 2. Now, do I have m? Yes, according to questions, the mass is 2 kg. So 2 omega square and A is 0.2. So square. Rearrange the equations, we obtain omega equals to 7.071 radian per second. Once you have omega, you can then calculate period because omega is equals to 2 pi over t. Right? So t is equals to 2 pi. Okay, 2 pi over omega, which is then equals to 2 pi over 7.071. So t is then equals to 0.89 seconds. So this is the answer, right? This is the answer. So you start from the equations. So start from the equation and then we obtain the value from the graph. So when K is equals to maximum, our X is equals to 0 according to the graph. Because K maximum, it happens at the y-axis, okay, along the y-axis. So y-axis, you have X equals to 0. So question C, the maximum acceleration. Okay, question C, maximum acceleration. So you just apply the equation. A max equals to A omega square. Okay, you have A, you have omega. Straight away, you can obtain maximum acceleration. So 0.2 times 7.071 square. Okay, which is then equals to 10.0 ms negative 2. So I know it's meter. Why? Because my amplitude is in meter. Okay, amplitude I have it in meter, so I know it's meter per second square. If my amplitude is in cm, then the A should be cm as negative 2. Alright, so saya akan lebih fokus pada unit. Sebab apa yang berlaku dalam exam, pelajar tak tahu tentukan unit. So how to determine unit? You look at the amplitude. The unit for acceleration, for velocity, for displacement, they all have the same unit as the amplitude. Okay, ada unit yang sama dengan amplitude. So amplitude in meter, A in meter. Kalau amplitude in cm, then accelerations Anda akan di cm as negative 2. Alright. So I give you 2 minutes to write it down before we proceed to questions 5. Okay, 2 minit untuk Anda catat sebelum kita bergerak ke soalan kelima. So, 2 soalan ini dia lebih fokus pada how to interpret the graph. What is the information that you can get from the graph? Okay, we learn how to get information from graph. So for questions 1 and questions 2, we learn how to sketch graph. Boleh kan soalan ini? Dia sebenarnya tak susah. Yang penting Anda faham graph. Okay, Anda faham kenapa graph dia bentuk begini. Apakah maklumat yang kamu boleh dapat dari graph? Di manakah maximum value Anda? Di manakah minimum value Anda? Max and mean play a very important role in chapter 9. Okay, max and mean play important roles in chapter 9. All right, questions 5. The last questions in 9.2. Okay, the graph questions. So an object, okay, a 0.2 kg object performs simple harmonic motion with displacement x from equilibrium position, as shown in figure. So you have x against t graph, and your x is now in cm, all right? Your x is in cm. So questions 1 determines the amplitude. So you have x against t graph. So amplitude is the maximum displacement. So we know A straight away is equals to xcm. Okay, A is equals to xcm. Straight away from the graph. So questions B. Questions B, calculate the angular frequency. Angular frequency is omega. Okay, it's not F ya. Jangan nampak perkataan frequency, kamu ingat dia adalah F. Ada perkataan angular di depan dia. You have an angular in front of frequency. So it is not F, but it is omega. So omega, well, based on the xt graph, the information that we can get other than A is the period. Okay, period. So we know t is equals to 0.8 second. Okay, and then omega is equals to 2 pi over t. Therefore, it is equals to 2 pi divided by 0.8, which is then equals to 7.85 radian per second. Okay, 7.85 radian per second. So this is questions B. Question C, calculate total energy. So total energy, you have only one equation. Okay, which is E equals to 1 over 2. Now either Ka square or m omega square A square. Right? So we don't have K. We don't have a simple harmonic. We don't have simple plot. We don't have spring constant. Okay, we don't have spring constant. Therefore, we use m omega square. So how do I know that I can use m omega square? Well, you have omega in questions B. So obviously, an equation with omega can be used in question C. Okay, kamu ada omega di soalan B. Jadi kita guna equations yang ada omega. If you are given spring constant, then you use E equals to 1 over 2 Ka squared. So ini kita kata teknik menjawab soalan. You try to look at the information. So what is the information given? If you are given spring constant, then you use equations with K. If you have omega, then you use equations with omega. So E equals to 1 over 2m omega square A square. You have A in questions 1, and then you have omega in questions 2. So straight away is equals to 1 over 2, 0.2. Omega is a 7.85 square. Now A, you have to be careful. A given is in cm. In our calculations of energy, we need to change it into meter. So 0.08 square, right? Which is then equals to 0.0394 joule. Actually, this is an improper way of writing down your answer. It should be 3.94 times 10 to the power of negative 2 joule. Okay, negative 2 joule. Cara yang lebih tepat. So this is what I told you. Okay, this is the things that you should do in your practical test, your report writing test. You write your answer in standard form. Okay, you write it in a standard form where the value in front of a decimal point is a non-zero value. Right? So you can have a single digit value and maximum you can have 2 digit, okay? Saya terima kalau kamu di depan decimal place kamu ada 2 digit, tak ada masalah. Sebab dalam report writing test Anda, jadual asal dia memang bagi kamu dalam bentuk 10, 11 begini, dalam nilai 10, 11 point something. So I can accept up to 2 digit, okay? But not 3 digit, all right? No 3 digit. So 1 to 2 digit in front of decimal point, and it is a non-zero value. So 0.0394 actually should be written as 3.94 times 10 to the power of negative 2. So you see, if you write it in this form, even though it is just 2 dp, but this is a 3 significant figures value, right? 3 significant figures value. So this is the answer for questions 5, right? So I give you a 5 minutes break now before we proceed to next subtopic, a new subtopic. So 5 minit rehat, Anda boleh salin dia, okay, Anda boleh rehat, pergi bancu kopi ke, pergi tandas, sambung balik pada 10 past 3, okay, 3:10 minit. So 5 minutes break. All right, so I hope no questions, yeah? Do you have any questions that you would like to ask? I hope you understand because this one is just a very simple questions where we try to extract information from the graph and then we learn how to sketch graph based on the informations given. Okay, it's a very short and a simple subtopic. So next one, 9.3 is also a very short and simple subtopic, right? So the things that we're going to look at right now is just two equations. So period of simple harmonic motion. We use expressions for periods of simple harmonic motion for simple pendulum and also single spring. So in our syllabus, we're just going to look at one spring. Okay, it's either horizontal spring or vertical spring. But both of them, they're going to use the same equations. So for simple pendulum, the equation is, okay, we have T equals to 2 pi square root L over G. Okay, if you look at these equations, it tells you that the pendulum, the mass of the pendulum itself, it doesn't affect the period, right? So if you look at spring, the period T is equals to 2 pi square root M over K, which shows you the period of a pendulum, of a spring, okay? The periods of a spring, it depends on the mass. So you have different equation for different system. Okay, that's why in your experiment 5, quite a lot of you gave me, okay, you need to use a heavier pendulum to obtain a more accurate time. I give you a wrong in your discussion because of this one. Because based on the equations itself, mass of the pendulum, it won't affect the period. All right, it won't affect the period. It just lets you get a nicer shapes of the oscillation. Okay, now let's look at exercise 4. A pendulum bob is suspended by a light string of length 100 cm. So you are given length equals to 100 cm, or okay, we say it is equals to 1 meter. It is pulled aside so that the string sweeps through an angle 10 degree with vertical. Aha! This one got one of you who got it wrong. 10 degree with vertical. Okay, so this is your hanging place. Pendulum initially is a hangings on the vertical line. So vertical bermaksud line garis lurus ini. This is vertical. 10 degree from vertical means now your pendulum is somewhere here and it makes an angle 10 degree with vertical. Sini 10 degree. Okay, in your video, practical test video, ada orang bagi saya 10 degree from horizontal. You give me 10 degree here. So this is wrong. Okay, this is wrong. So you can't do anything now. It's too late. Alright. So kamu tak hantar untuk draft, untuk first review. So kamu buat salah, memang tak boleh buat apa-apa dah. Alright. 10 degree from vertical. Okay, bukan 10 degree from horizontal. So it should be like this one. Okay, like this diagram. So now I have a 10 degree from vertical. Okay, so I have a pendulum here. So this is a vertical line. So you pull it aside. Okay, you pull it. So now your pendulum is located at here. And then you release it from rest. So initially it's at rest. So this is the maximum position. Okay, the maximum position. So what happened next? Okay, now I release it and question asks me to calculate period. So how to calculate period? Period is T equals to 2 pi square root L over G. So you have L, okay, length, which is equals to 1 meter. G, well, G is a constant value. So we know G is equals to 9.81 ms negative 2. Okay, that is the values of G. So straight away you can calculate T. T is equals to 2 pi square root 1 over 9.81. So it is equals to 2 seconds. Okay, it is equals to 2 seconds. Questions B. Okay, questions B. How are we going to solve questions B? Ya, Nida, apa soalan? Oh, tak ada, tertekan.
Tidak ada.
Okay. So, questions B, the speed of Bob when it reaches the lowest point of its path of motion. Okay, so you want to calculate the speed when the bulb reaches somewhere here, okay, the lowest position. So at this lowest position, okay, we know that K is equals to 0. K is equals to maximum, sorry. K is equals to maximum, and your U is equals to 0, right? So now we want to calculate the value. So what is the equations that can we use to calculate it? Now you look at the questions. Seems like we don't have. Okay, we don't have an omega. And then what else? Okay, can we calculate it by using K equals to K equals to 1 over 2 m omega square, well, maximum value. So maximum is a square. Okay, can we calculate it by using these equations? Well, obviously cannot. Why? Because I don't have mass. Okay, mass is missing. So mass is missing, which means we cannot solve it by using this equation. So what is the other equations that we can use in this system? Well, if you recall, when something oscillates, we have E equals to K plus U equals to 0. Equals to 0, equals to constant, sorry. Constant because of the conservations of energy. All right. So if you cannot use the one in a simple harmonic motion, then we try to use the one from chapter 5. So K initial plus U initial equals to K final plus U final. Okay, kita tak boleh solve dengan M omega square, A square kan. So kita cuba guna equations daripada chapter 5. So what are we going to do? Okay, K initial 1 over 2 MU square plus MGH initial equals to 1 over 2 MV square plus MGH final. Okay, we try to solve it by using these equations. So what are we going to do next? Now, initially your object is at rest. Okay, it's released from rest. So initial kinetic energy is equal to 0. And then when it reaches lowest point, so lowest point here, we assume H equals to 0. So your H final is equal to 0. Therefore, for U final is equal to 0. So we are left with just this equation. MGH initial equals to half mv squared. So you want to calculate V. Okay, you want to calculate V. But now one question is, we don't have H. Okay, we don't have H. So how to calculate H initial? That would be the question. Okay, so initially my H is equal to 0. Okay, my bulb is located at here. So my H initial, okay, this is my H initial. Okay, H initial is right here. This is H initial. Can I determine H initial? Yes, you can. Okay, you can determine H initial. How? If you look at this question, it's actually forming a right angle triangle here. Okay, dia bentuk satu segitiga di sini. Right? Oops. Where you have the hypotenuse length L, you have the angles 10 degree. Okay, so now what we want to calculate is the height. Okay, we want to calculate this length. Okay, we want to calculate this length. I'm going to call it X. So if you look at this question, if you look at this diagram, when your object, your pendulum is located at the lowest position here, okay, kalau pendulum kamu berada di lowest position, this one, it means L is actually equals to X plus HI based on the diagram. At lowest position, dia beritahu kita bahawa X plus HI, it is equal to the length of the pendulum. Okay, lowest position. So at lowest position is here. So HI is equals to L minus X. Okay, HI is then equals to L minus X. So we need to determine X from the triangle, from the right angle triangle. So X is equals to, kalau tengok graph ini, okay, you have, this one is a side, hypotenuse. So cos 10 degree is equals to X over L. Okay, so your X is equals to L cos 10 degree. So HI is then equals to L minus L cos 10 degree. Okay, H initial kamu. So you sub it into the equations and eventually you will obtain V equals to 0.548 m as -1. So cancel out the m, you have v half v square equals to gh. So you sub everything into the equations, you will obtain v equals to 0.54 m as -1. Right? So yang penting you look at the diagram of the pendulum. Okay, kamu tengok pendulum punya diagram. So I will repeat it again because this part is a bit complicated and usually students got it wrong. Right? So initially we have a pendulum. Okay, this is the initial position. This is the vertical line. So initial position of the pendulum is here. All right, this is the initial position and this is the length. So this object is swinging. Now at its lowest position, okay, this is a pendulum at its lowest position. So let's say it's here. Okay, this is at the lowest position. So lowest position is still have the same L. Okay, dia masih ada same L. But what we do know now, okay, we want the height of the object at its initial position. Okay, kita nak height dia. Okay, we want the height. This is our HI. So we want to find out what is the values of HI. So what are we going to do? So we need to find the length of this part first, of the X first. Okay, kita nak cari X ini. So how to calculate X? Now this is the angle. We have length here, L. And now we have X. So it's forming a right angle triangle. Okay, dia bagi kamu satu right angle triangle. Di mana L di sini, X di sini. And the angle is 10 degree. Okay, the angle is 10 degree. So once you obtain X, okay, then you will have the values for HI. So HI is actually, okay, saya padam sikit. HI is actually from the lowest position. Okay, this is when H equals to 0. So HI is here. Okay, HI is here. So based on the diagram, I know HI plus X equals to L. Sebab apa? Sebab warna purple punya length ini. Okay, this length is still equals to 1 meter. Okay, it's still equals to 1 meter. Sebab pendulum, your pendulum is swinging. When it's swinging, the length of the pendulum is fixed. Okay, so length there is still 1 meter. Just that now, okay, it's a different position. It's located at different position. So based on the diagram, okay, based on the diagram, I know that L is equals to HI plus X. Okay, so nak kira HI, the initial height. So HI is equals to L minus X. So what happens to X? Based on the triangles, the green color triangles, X is equals to L cos theta. Okay, so theta given 10 degree, X is equals to L cos 10 degree. So you sub it into the equation. Okay, L minus L cos 10 degree. That is our HI. Okay, that is our HI. Yang kita nak kira sebagai initial height of the object. Alright, initial height. So the lowest position is the final height. So final lowest position, equilibrium position, we take it as H equals to 0. This is our assumption, of course. Okay, we assume H equals to 0 at lowest position. Alright, so can you understand how to determine the H? So soalan ini dia susah dekat mana? Dia susah dekat cara determine H. Alright, so this is the complete solution for question number 1B. Okay, 1B. So basically saya cuma ulang sahaja. Okay, ulang untuk orang yang masih tak faham diagram ini. So this diagram, okay, and the one on the right hand side, actually they are the same. Okay, they are the same. So cuma saya terang 2 kali sebab dia complicated sedikit. Saya takut Anda tak faham. Right? So you just write down either one and then you write out the solution. K initial plus U initial equals to K final plus U final according to the conservations of energy. So the reasons why we cannot use the equations in a simple harmonic motion, that is because of the, we don't have the mass. Okay, we cannot straightaway apply the equations. But we can use the equation from chapter 5. Right? It's the same. Because energy is a scalar quantity, the directions of traveling, the directions of motion is not important. You look at its initial position and final position. That's it. Right? Okay, so bagi anda beberapa minit untuk catat. This is the hardest question if I'm not mistaken. So after that, we'll go through the questions 2 and questions 3 and 4. Okay, quickly. Dia akan senang dah soalan seterusnya. Okay, so any questions? I hope no ya. Sebab diagram ini dia actually penting because quite often questions will ask you to calculate X or HI or even amplitude. Questions 4 we look at how to calculate amplitude in this type of questions. Okay, in this type of questions. So, cuba fahamkan. Okay, diagram ini yang susah saja. Cara pengiraan dia senang. Okay, cara pengiraan dia senang. Okay, now questions 2. So questions 2, particles of mass 4 kg. So now you have m, so it makes your life easier without with an m in the equations. So particles of mass 4 kg undergo simple harmonic motion. Figure shows how the potential energy of the system changes with displacement. So determines the period of an object. So if you look at this diagram, again, the information that you have is amplitude, negative amplitude, and then positive amplitude. And then here is x equals to 0. So this is your U maximum. Okay, your U maximum. So in order to determine the period, we need omega. Okay, so this one is very similar to the questions that we've seen in exercise 9.2 just now. So U max is equals to 1 over 2 m omega square a square, okay, because the x maximum is equals to a. So U max is equals to 1 over 2 m omega square a square, and then it is equals to 1 over 2, okay, 10 joule, okay, 10 joule is equals to 1 over 2, 4 kg, omega is the one we want to calculate, and then A is 0.2, okay, 0.2 times 10 to the power of negative 2. Now, why times 10 to the power of negative 2? Because you are given cm in a graph. Okay, so you need to change it into meter because your energy is in joule. Okay, energy is in SI unit. So A must also be in SI unit. So rearrange the equations. Omega is equals to 1118.034 radian per second. So by using T equals to 2 pi omega over omega, it is then equals to 5.62 times 10 to the power of 3 second. Okay, millisecond. So that's why in the answer, it gives you in terms of a milli, okay, ms, because of a times 10 to the power of negative 3. So that is how you determine period. Very simple, okay, very simple. From questions, you determine omega, because omega and period, they are one big family. So once you have omega, you can then proceed to determining the period. Okay, so this is just a very short and simple questions. Now next one, questions number 3. So when a family of 4 with a total mass, okay, total mass 200 kg step onto their 1,200 kg cars, the car spring compressed, okay, by 3 cm. So what is the spring constant of the cars, assuming they act as a single spring? Okay, so now how to solve this question? So let's see. Initially, you have just a car, okay, and then you step onto the car, and X, okay, the X compressed, the spring compressed by 3 cm. So you have X equals to negative 3 cm, because now your vertical spring is being compressed. Okay, so how are we going to solve it? You step into a 1,200 kg car. So the total N that we have right now, okay, so initially this is a spring. Okay, so this is a mass of the car. So now you have a person step onto it. So now you have together with the mass of family. So the spring is being compressed. Okay, it's being compressed by 3 cm. So X equals to negative 3 cm, and we have M equals to 200 kg plus 1,200 kg. Okay, 1,200 kg. So it is like you are hanging mass on a vertical spring. So initially, the spring is at its equilibrium position. And then you hang a mass, it starts to stretch the spring. Okay, it starts to stretch the spring. So this is what happened. Okay, this is what happened. So now my M total is equals to 1,400 kg. So what is the spring constant of the car? So questions A, F equals to negative kx. Okay, so the force is now equals to the mass of the mass of the what? Mass of the load. Okay, mass of the load. So now you have a mass which is equals to, let me see. I need a calculator first. Okay, wait, yeah, let me get a calculator first. So 200 times Okay, so now what are we going to do here? Okay, we have to look at the mass, okay, in terms of two different things. First thing, we have F equals to Kx. Okay, so we have a Fs here. So this Fs is actually the restoring force. Initially, you have a load which is an m car. Okay, and then when you add this 200 kg, it compresses the spring by 3 cm. So now what are we going to do right here? We are just going to use the weight of the family, okay, which is 200 kg, sorry, 200 kg to calculate the restoring force. Okay, so this is the initial position. Okay, this is the initial position. And then this is the positions after being compressed by 3 cm. And this 3 cm is caused by, okay, is caused by 200 kg of the family. Therefore, here we want to use the weight of the family, okay? W family equals to negative kx. So W family, we have 200 kg times 9.81 equals to negative k and then negative 3 cm, which is 0.03. So rearrange the equations, we obtain k is equals to 65400 nm negative 1. Okay, 65400 nm negative 1. So we use the weight of the family because this 3 cm, the compressions of 3 cm, is caused by the family. All right, it's caused by the family. So now questions B. Determines the period and the frequency of the cars after it hits a bump. Assuming the shock absorber, they are so poor, okay, they're poor, so the cars really oscillate up and down. Now, questions A and questions 2, they are slightly different. Questions A, this restoring force, okay, because we are looking at x equals to 3 cm, and this 3 cm is caused by just the family. So we use the mass of the family. Okay, we use just 200 because this is the mass that caused the compression. Okay, 200 kg, okay, 200 kg compressed spring, by 3 cm. But in questions B, now what happened is the whole thing, it oscillates up and down, including the car. So for questions B, the mass that you need to use is 1,400 kg. Okay, it's unlike questions A. Questions A, you use mass 200 kg, but questions B, you use 1,400 kg. Because now you are treating this object as a whole, okay, as one item. So now your spring oscillate and is bringing this total mass bumping up and down, oscillating up and down. So to calculate period for a spring, so T equals to 2 pi square root m over g. This m is a total mass. Okay, this m, you need to use total mass because now this whole thing is oscillate as a whole, all right, as one object. So T is equals to 2 pi square root 1,400 divided by 9.81. Okay, which is then equals to 0.92 second. Okay, 0.92 second. So once you have time, you have period, you can then calculate frequency because T is equals to 1 over F. So F is equals to 1 over 0.92, which is then equals to 1.09 hertz. So this is the answer. All right, this is the answer. So the crucial thing is in this question is to know when to use the mass of the family and when to use the total mass of the two objects. All right. So initially for questions A, we use 200 kg because this compression, okay, is happening. This compressions of 3 cm is happening because of this 200 kg, not because of 1,400 kg. Alright, kalau compression disebabkan oleh 1,400 kg, then di sini M kamu guna 1,400. But now, according to the question, the compression is caused by 200 kg, okay, the mass of the family. So untuk restoring force, okay, restoring force is actually equals to W, okay, W of the family. So for this question, F restoring is equals to W family. Okay, kalau kamu compress dengan 200 kg. Okay, so di bawah, according to Newton's third law, dia akan cuba tolak balik dengan 200 kg punya weight. Okay, 200 kg punya force. So W restoring is actually equals to the weight of the family. So family tekan dia begitu banyak, spring akan cuba tekan dia, tolak dia balik dengan force yang sama, according to Newton's third law. Okay, that's why Fs equals to negative Kx, Wf is equals to negative Kx. So kamu ada W 9.81 equals to negative K negative 0.03. So from here you obtain spring constant. Okay, you obtain spring constant. Oh, saya ada salah isi di sini. Sorry ya, I make a mistake here. So it should be K. M over K. So your K is 65400. So from here you obtain the period. Okay, you use K from questions A in a questions B. All right, you use K from questions A in questions B. So T equals to 2 pi square root M over K. From here you obtain period. By using period, you obtain frequency. All right, so I give you 4 minutes to write it down. Okay, 4 minutes to write it down to understand this question. So we'll continue again at 3:45. So make sure you understand these questions. Okay, kalau ada mana-mana yang kamu tak faham, kamu kena tanya. Kenapa soalan 1 guna 200 kg? Kenapa soalan 2 guna 1400 kg? Okay, that is because the object that we are looking at different object. First one, we just look at the family. The second one, we look at the car and the family. Because now car and family, they are acting as a one object. They are combined as a one object, and they are oscillating together with the spring. Okay, so harap anda boleh faham ya. So soalan di chapter 9 ini, anda kena boleh imagine. Okay, you need a bit of imagination to answer the questions. Okay, so now we're almost done. The last question. So last questions, this one is very similar to questions 1. But now, rather than height, it's asking for amplitude. So you need to know where is the amplitude in a simple pendulum. Okay, in a simple pendulum. So again, I'm going to start from a diagram. So a simple pendulum of length 80 cm is released on the Earth's surface at an angle of 8 degrees to vertical. So now you have, again, a simple pendulum. This is a vertical line. Okay, and then this is your pendulum. So 8 degree. Okay, 8 degree. So initial position is 8 degree to the vertical. Calculate the period of oscillation. Now, this question is very simple. Questions A, period, you have just one period. So T is equals to 2 pi square root L over G. You are given length 80 cm. So 2 pi square root 0.08 divided by 9.81, which is then equals to 1.79 second. Questions B, calculate the speed and accelerations of the pendulum bob when it passes through the lowest point. So what happened at lowest point? Okay, so this is the lowest point. Let's say now my pendulum bob is at lowest point. At lowest point, okay, x is equals to 0. Therefore, we know potential energy is equals to 0. Okay, so when the potential energy equals to 0, our kinetic energy is equals to maximum. Now, why is it important to know what happens to the kinetic energy? Because if kinetic energy is maximum, it means that your V is max at lowest position. Okay, maximum V at lowest position. So at this position, okay, at these positions, we have V max. So how are we going to calculate V max? Okay. Now, V max, according to what we know, is A omega, okay, in a simple pendulum, in a simple harmonic motion. So how are we going to calculate it? Okay, let's see. This one. So if you want to calculate V equals to A omega, you need A. Okay, omega can be obtained from T because omega is equals to 2 pi over T. Okay, so it's a very simple. Straight away you obtain omega is equals to 2 pi divided by 1.7. Okay, so you get the value here. Now the problem is A. How to determine A? Well, we have length here. Okay, length is equals to 80 cm. When it comes to a pendulum, the oscillations of pendulum, the reason why we take a very, very short angles is because we assume, this is an assumption, we assume our object is moving in a straight line. Okay, so A is actually the displacement here. This is our X. So X happened at maximum amplitude. So when X is located at 8 degree, that would be the values of A. Okay, at X max is equals to A. So again, you have a right angle triangle here. Okay, right angle triangle here, where this is your L, this is your amplitude now, this is 8 degree. All right, so rather than the height, now we find the amplitude, the horizontal distance, the horizontal part of the triangle. So this is a right angle triangle. So now A is equals to L sine 8 degree. Okay, so just now we were looking for height, so we use cos. Now we were looking for amplitude, the horizontal displacement. So we use A equals to L sine 8 degree. Okay, so yang kamu kena tahu when it comes to displacement in a simple pendulum, it's actually referring to here, the horizontal distance from equilibrium position. Okay, the horizontal from equilibrium position. So A in this case, you can calculate it by using L sine 8 degree. So A equals to L sine 8 degree, which is then equals to, I have 0.08 meter, 80 cm is 0.08 meter, sine 8 degree. So A is equals to 0.11 meter. Okay, so V max is then equals to 0.11 times 2 pi over 1.79, which is then equals to 0.39 ms negative 1. Okay, so for amplitude, and for amplitude, for acceleration, so A max is equals to A omega square, if I'm not mistaken. Okay, X omega square. Okay, X omega square. So A max equals to x omega square. At the lowest position, my x is equals to 0. Therefore, A max straight away equals to 0 ms negative 2. Okay, equations there. Equations A max. Okay, equations A max. So A max is equals to x omega square. That is according to the definition. So at lowest position, x is equals to 0. Therefore, I have 0 ms negative 2. Okay, 0 ms negative 2. Bukan A max, sorry. A sahaja. Okay, A sahaja. So A is equals to x omega square. So x omega square, x sama dengan kosong. Therefore, I have 0 ms negative 2. Alright. So ada V max. Okay, the reasons why I know V max is because of K max. So A, the equation, the simple equations, the basic equation is x omega square. Therefore, you have 0 ms negative 2. Alright, so that marks the end of chapter 9. Okay, that marks the end of chapter 9. So any questions? Oh yeah, I forgot about question C. If the same pendulum is brought to Mars with gravitational accelerations of 3.71 ms negative 2, would the period of oscillations remain the same, increase, or decrease? So if you look at the equation, okay, if you look at the equations here, okay, you look at this equation, T, okay, T is proportional to square root 1 over G, okay, square root 1 over G. So if G Mars is less than G Earth, then the T Mars would be greater than T Earth because they are inversely proportional, okay, according to relationship. So based on this relationship, since G Mars is less than G Earth, therefore T Mars is larger than T Earth. So we derive it based on the relationship. We just look at the relationship. Now, of course, some students, they like to use the calculations, okay, because they don't know how to solve it by using relationship. Also can, okay, also can. So you calculate it by substitute G equals to 3.71. So from there, you will see that T on the Mars is larger than the T on the Earth. Okay, so ada yang kalau tak reti pakai equations, tak reti pakai relationship, boleh juga pakai nilai. Okay, kamu boleh ganti G dengan 3.71. And then kamu kira and then banding, compare the values that you obtain with the value from questions A. Okay, you compare and then see which one is larger, then you make a conclusion. You can do it in this way because the questions didn't ask you to solve it, to explain it in a qualitative form. Okay, kalau soalan nak Anda, okay, minta Anda explain qualitatively, then you must show the equation. Okay, kalau soalan ada sebut perkataan kualitatif, okay, explain qualitatively. Then you need to explain by using this equation. If question asks you to explain quantitatively, then you have to find the value. If the questions didn't mention anything, then it is up to you which one you want to use. Okay, boleh faham? So soalan explanation dia ada 3 jenis. Okay, yang biasa punya adalah macam soalan ini. Dia tak minta kualitatif ke kuantitatif. Kalau dia minta kualitatif, Anda mesti tunjuk equations dalam warna hijau ini. Tak boleh ada nilai. Okay, you cannot have value. Because qualitative, it wants you to explain based on the theory, based on the relationship, and so on. Kalau dia minta quantitative, then you calculate it by using 3.71. Okay, you calculate T Mars, and then you calculate T Earth, and then you compare the value. The one we call explain quantitatively. Alright? Quantitative, quantity. Qualitative, tanpa nilai, tanpa quantity. So make sure you understand the question. Alright, explanation types question. So if it didn't mention anything, then it's up to you. Whether you want to use quantity ke, you want to use a sentence, you want to use the theory, it's up to you. Right? So that marks the end of chapter 9. Right, that marks the end of chapter 9. Once you have write everything down, if no questions, then you may leave the class. Okay, kalau tak ada soalan, Anda boleh leave class.
Thank you, madam. Thank you.